Let's take a look at the following question. Let's say we wanted to solve this particular inequality, and notice that we have x squared plus 7x plus 12 is greater than or equal to 0, which is a good thing that everything, notice, is on the left-hand side. You have your inequality symbol and you have a 0 here on this side. You always want to have a 0 on the right hand side. Now what we're going to do is the following: try to find for which x's this inequality is satisfied and write the solution set in what we call interval notation. Now let's just do one thing. Let's just focus on this particular function, which is f of x or y is equal to the left hand side, this quadratic function here. Now let's call on the calculator Desmos just to see a little bit what it looks like. So if you go to desmos.com, let's go ahead and type in the equation. We have x quantity squared, and then it's going to finalize the graph to look exactly like what we need in just a moment. I'm just typing in the pieces: plus 7x, and then we have plus 12. So this is what this graph looks like for the function which is on the right hand side of this inequality. Let's remember we're trying to go ahead and think about this inequality. So I type y is equal to the right hand side, the quadratic function. Now let's do the following. Let's just kind of analyze what's happening here. Notice we have the point -3, 0. We have the point also -4, 0. So those are the x-intercepts for this particular function. So we may want to think about writing the following. Just one second. Okay. So if we have over here the 2 points, we have the x-intercepts. Notice we have the point -4, that's for x, and when x is -4, y is 0, our function is 0. And we have the point -3, 0, when x is -3, y is 0 also. So those are two special points that we have. And notice for both of those points, y is equal to 0. Y, or remember what y stands for? So y is equal to 0 for those 2 points. Now what else is happening? Those intercepts are where the graph, which is a parabola, is crossing the x-axis. So right here and right there, we have y equal to 0. And then let's take a look further at what's going on when we're considering values of x that are not -4 and -3 per se, but any value of x that goes from -infinity to -4. What's going on right here? What is y doing when x has such a value? What are the y values over here doing? And then when x is -3 or bigger, what can I say about y? Okay, so do remember that when x is specifically -4 and when x is -3, for those two x values, because they correspond to those points, for those points y is 0. Now let's do the following. Let's just be on the graph a little bit for a value which is more negative than -4. And let's just, stay on that graph. Notice when the x values are more and more negative than -4, then the y values, which is a second entry of the point that is labeled, the y values are positive. Okay, so the y values are positive like this. If I go on the other side right here, now for this point, the y value is 0. at the point -3, 0. But if I go and I pick a value of x which is slightly bigger than -3, the y values are positive. So what's happening is the following. If you think about it, when you have a y-axis, if you have a graph which happens to be drawn like this one, then for those points on the graph, because those points are above the x-axis, for all those points, the y values will be positive for those points on the graph. And those points on the graph corresponds to x values that are, in this case, less than -4, and for those points right here, bigger than -3. So here x is bigger than -3, and here x is less than -4. And for those particular x values, the y values are positive. You are above the x-axis for those points. And one more thing. So y would be positive for x being less than -4, which you call x being between -infinity and -4, and also for x being bigger than -3, so -3 to infinity. And that's y strictly positive. I'm not talking about y being 0. Y was 0 specifically for x being exactly -4 and x being exactly -3. Now, where do you think y would be negative? And when I say y, keep in mind, y stands for this quadratic equation, okay? Quadratic function over here, I should say, quadratic function. So where is y negative? Y is negative for the points of the graph that are over here below the x-axis. And let me show that to you. If I were to start at this x-intercept, y is 0, okay? But if I go for a value of x, which is slightly bigger, than -4, so then -3.92 and so on, all the way to, let's not touch x being -3. Okay, if you keep your x values between -4 not included and -3, then you have y value. Look at the second entries of those points. You have y values that are negative. So that's exactly, what we notice over here. So y is negative when the x values are between -4, -3. That's for x, for those x values here. So that's a little bit what we notice over here. And I will try to make it a little nicer here for you. I'll draw a little graph so we can see all of those details. So if you take a look at the following, you notice that you have, for this particular point, you have the point -4, 0, which is the x-intercept. You have another point which is -3, 0. Remember what y stands for. It is the function x squared plus 7x plus 12. So for those 2 points, the y value is 0. And that's when x is -4 and x is -3 exactly. So y is equal to 0 when specifically x is -4 and x is -3. Now what else do we notice? We notice the following, that if you're considering this portion of the graph and this one as well, okay, we call that your y-axis runs this way. So this is your y-axis at some point, and then you have your x-axis over here. So for those blue points, any blue point I pick, you will have whatever x is, comma, and y will be a positive value because this is a point above the x-axis. So for all those blue points I highlighted, y is positive. Y is positive. And that's for which x's? For the x's that fall, to the left of -4, for those x's, not included -4. Remember, at -4, at x equal to -4, y is specifically 0, and we want y strictly bigger than 0. Okay? So for those value of x running from -infinity to -4 not included, y is positive. So for x in the interval -infinity to -4, parentheses on both of those, we have the y value being positive also for those points right here. Okay, notice this point is whatever x is, comma, y being also positive. So x, you would find how much x is by coming here. So for those x values, starting at -3, not -3 being included, all the way to forever to the right to infinity, then y would be positive as well for x in -3 to infinity. So that's what we have. So we can summarize that. We can say that y is positive when x is an element of, or when x belongs to this particular interval on the left. And let's not forget, x could be here or x could be there for y to be positive. So we need to put a union here, and then we pick up on the other side with -3 comma infinity. And finally, what's going on in this little portion here of the graph? Okay, so for this portion of the graph, if you pick any point, then x would be whatever it is here, falling between -4 and -3, but y would be negative. Why is y negative? Is because we are below the x-axis, so we get a y value that's negative. So y is negative when x is sandwiched between -4 and -3. So when x belongs to that interval. So y is negative in the green portion of the graph when x is an element of the interval -4, -3. So let me write that. That's one more thing we have. And let's see. That y is negative when x is an element of, on the interval you could say, -4, -3. Now I'll say one last thing. They wanted us to solve over here the inequality x squared plus 7x plus 12 greater than or equal to 0. So for the greater than portion of that statement, x will be in this interval. Now when they say greater than or equal to, when they talk about the little equal being part of that, you modify this blue interval to now accept those end values. So the solution set of what they're asking is -infinity, -4, square bracket, union, square bracket, -3 infinity.